this, digital forensics is like a huge thing that I've like wanted here at Western. I transferred from Davenport University. We had a pretty cool digital forensics program. Keyword had. Um, um, we did a lot of cool stuff there, and John was my roommate, and he was going there specifically for digital forensics. He is incredibly knowledgeable on the topic, and will
I
be.
wouldn't say
Uh,
that, but I do
Come on,
have.
John. Let me give you credit here. He's got a little bit of imposter syndrome, but intelligent, incredibly knowledgeable. This will just be going over like basic concepts of digital forensics, mostly on like Windows devices. But um, right?
Yes, yeah, I'm gonna get into that in a second.
Okay, I'll let John take it away.
All right, so hello everyone. I'm John, digital forensic analyst at Champlain College's Leahy Center in Burlington, Vermont. I am a digital forensics major. I'm a senior. I'll be graduating in a couple of months now, and I have a minor in criminal justice.
Yeah, I'll
So
mute
I'm
on Discord.
focusing more on the law enforcement side of things than the private sector. I focus more on the criminal aspect than the um, data recovery side, although we are going to be doing some of both across both of the sessions today and tomorrow. Um, I'm a level 2 investigator, so I work directly with clients at the Leahy Center. Some of our clients are law enforcement based, some of them are private. I am professionally certified with a few different certifications. I have the Magnet Certified Forensic Examiner. If you don't know, Magnet is the sort of the big company in digital forensics. They make Axiom, which I'm going to be going over in a minute. That is an all-in-one forensic suite that a lot of law enforcement agencies use. They also make Griffi, which is a case publishing platform, and then they also make GrayKey, which GrayKey is a very big thing for mobile forensics. It helps bypass iPhone log screens and encryption. I'm also certified in oxygen forensics. I have my oxygen forensics academic certification, which is a mobile forensics platform. So I do know both the desktop side of things and the mobile side of things. And then I also have my Security Plus for cybersecurity. For digital forensics, you have to know a lot about cybersecurity. The two fields are pretty intertwined. You can't really know all of one without knowing some of the other. And then I also compete on a team for the CCDC, the Northeast region of CCDC. So I do know my stuff on cyber. I'm not probably quite as versed as you guys are over at Raven. It's not really my focus anymore, but I do know enough. I do want to get into some things before we get going. I made these slides with the idea that most of the people watching and listening will not know very much about digital forensics. So, some of you, I'm sure, do know some, and you might be bored for the first 15 minutes of the speaker segment. I promise I will get into some of the more cool stuff later on, but I do need to start off with some of the basics to make it a little more understandable for less experienced people. I also do want to make clear that I am still a student. I am not a teacher. I am not a multi year industry veteran or anything. Um, I do know enough to talk my way around the subject, but please do not take my word as gospel. I do not know everything there is to know about digital forensics. I probably will never know all of that there is to know about digital forensics. So for this session, I'm gonna try to make it between 30 and 45 minutes of me talking, and then we're gonna have a lab afterward. I have not rehearsed this speech. See my comments previously about being a student. I am busy. I have a lot of other things to do. I already had to get an extension on a paper to finish just the labs, so I haven't had time to rehearse. So I will try to make it between 30 and 45 minutes. If it takes longer than that, feel free to take a break if you want or leave. It'll be recorded so you can look at it afterward. Um, Generally, what I'm going to be covering is you guys are mostly cybersecurity focused from what I can tell. I'm going to try and link what digital forensics and incident response have to do with cybersecurity and how the two fields sort of interlink. Then I'm going to be going over file carving, which is a way of data recovery out of volumes that you can't access by normal means. I'm going to be going over some of the common artifacts. Artifacts are basically just traces of things on a computer system. It can be files, it can be network traffic, it can be execution records, it can be really anything that shows what happened on a system. And I'm going to be going over some of the most common ones of those. Unfortunately, I don't have nearly enough time to cover all or even most of the artifacts that can be found on just Windows systems. And then we're going to be going over tools, some of the most common digital forensics tools that we use for different kinds of cases and different needs within those cases. And then I'm also going to do a lightning round where I have several extra artifacts and digital forensics concepts where I'm not going to really do designated slides. I'm going to kind of just glaze over what they are, talk about them for a second or two, get you guys introduced to the concepts, and then move past them. And then at the end, we're going to have a section for questions if you guys get lost or if you have anything you want to ask me. And then we're going to cover what we're doing tomorrow at the end as well. So, digital forensics and incident response, which is DFIR, that's the acronym you'll see all over the place and in the industry. It's two separate realms that work together, both with cybersecurity. Digital forensics is my degree. It's what I'm training for. It's what I'm more experienced in, but I do have experience in incident response as well. Forensics is more meant to go through methodically, figure out exactly what happened on a system, create a timeline, um, figure out where the actor got in, exactly what they did, everything that they did, and then figure out the full extent of the damages. Whereas incident response is more of the immediately after something has been detected, you go in, you try and figure out generally what happened. You usually don't end up focusing on some of the smaller details. You just try and figure out where the breach was and patch it up so it can't keep getting worse. And then you sort of take down evidence and hand it off to digital forensics teams. So both of these sort of link into cybersecurity because they are subfields of cybersecurity. Cybersecurity encompasses risk and governance. It encompasses forensic investigations. It encompasses creating active defensive measures, endpoint detection and management. It's a very broad, overarching field. And forensics and incident response is more of the figuring out what happened after an incident aspect of that. So it's something that you guys, being cyber professionals, you'll need to know at least a little bit of, and you'll definitely be exposed to. If you get into a SOC team, you'll definitely be looking into. Okay, we had this alert on our endpoint detection system. Where did that come from? Why did it happen? What's indicating that it's real or fake, positive or negative? And you'll need to go through and figure out exactly what that relates to the incidents that you see in the SOC. So next thing we're going to go over is file carving. Like I said, it's a method of file recovery. So generally, it's for when you have a volume that you can't access by standard means, and you want to get files out of it. You can take the signatures, or magic numbers as it's sometimes called, which is the hex code that identifies a specific file type. You find the start of that file signature, the header is sometimes called, and you will carve between the header and the footer of the file, which is also like the header, except it's at the bottom of the file and marks the end of it. Some files don't have footers. Generally, those files are more annoying to deal with. One example is bitmap files, .bmp extension files. They do not have a footer, but they have information at their or right after their header that designates this is how large the file is. So you have to parse through some of that information following the header, and then figure out how large the file is, and then you'll carve from that starting signature at the header all the way down to the total amount of bytes that the file size shows, and then you'll get your file out. Generally, like I said, it's used for unformatted volumes and corrupted volumes that you can't really access by the normal means of like File Explorer or trying to mount it. But it can also be used for counter forensic detection. So sometimes you'll have people that during a cyber incident will try and hide their tracks, and they will sometimes smash up different files to try and hide what they did. And file carving is a good way to get those files back out. So a demonstration that I have for PDF files, going to be going over file carving from a VHD, virtual hard disk. So we're going to open this corrupt disk in a hex editor. So if you don't know, a hex editor is a tool that allows you to view the bytecode of a file. Bytecode, sometimes people think of it as binary, as ones and zeros. Generally, that's not how we deal with it because that's not human readable. So what you're going to see in most of forensics is you're going to see a hex view like this, where it's got the hexadecimal values, which is
Hey,
base
John, can you make that
16,
a little bigger?
a little bigger.
Yeah, yeah.
Uh, is I don't know if there's a zoom
Control plus,
function.
maybe?
Less?
No, I said control plus,
No, I
maybe?
tried that. That's not working.
Oh. Uh,
Hmm.
here. This is mine. Here, we'll go to what? Hmm. Maybe it's just because of the size of your screen.
Maybe. Control plus and control wheel are not working.
Here, just open it. Hold up. I got this. For those at home, I'm zooming in on it. In the Discord call, in WebEx you can physically zoom in on a thing. So the people in the the class could see this, but and the people on Discord could see it. But I don't. I think we're good.
We're good. You can see it, kind of, a little bit. Okay. So you can tell I didn't
Good enough.
rehearse. Um,
Yeah, it's fine.
so for a PDF file, we're gonna go over to our handy dandy Wikipedia link for a list of what file signatures are for what files. And we're going to look up PDF. So this hex value right here, that little string right there, that is your header, or your magic number as it's sometimes called. We're going to copy that. And we're going to do a control F to look for hex values. We're going to switch to the hex value tab. Search direction all. And then we're going to search all. It's going to think for a second, and we found the start of our PDF. So we're going to want to note down this offset right here. So I'm going to open up a little notepad document. We're going to note down the hex offset is 15C 8F53. And then we're going to go back and type that. And then we're going to look for trailer. And then right here, this %% EOF end of file marker is the trailer for a PDF file. So we're going to go back to our find window. We're going to go to text instead of hex. We're going to go %% EOF. Search all. It's going to think again. And we found the end of our PDF file in that volume. So we're going to note down this offset at the end, 15DF FC0. And then we're going to go edit and select a block. We can leave that value in the end offset. We're going to set our initial value for the header. And that's going to select the whole file. We're going to do copy. We can just make a new file with this little page button up here. Paste, save it, change it to a .pdf. And then we click on it. And would you look at that? It's a working PDF file. And that just as a demonstration, this is the original file. You can't mount it normally. You can't use it to open the PDF by normal means. So we've got a working PDF out of a volume that the average user would be able to do nothing with, which is pretty neat. And that's what file carving is. And we're going to have a lab doing that. You guys are going to get hands-on with this tool here in a bit whenever we finish the speaker segment. Okay, close all this out. Get back to here. So the next thing we're going to go over is some of the most common artifacts in digital forensics, specifically Windows artifacts. We got prefetch, which is an execution artifact. It proves that a program was run on a system, and it records some of the information about it. We'll get into that in a second. We're going to go over the registry, specifically what some of the most common registry paths are for forensic investigations. The registry is a Windows system's complete record of all of its configurations and all of the basic information about the system. It stores a whole lot of forensically valuable information that you can use to identify a system. Event logs is, I guess I would kind of equate it to a more running record than the registry. The registry is more your static configurations that will occasionally change, whereas event logs is a constant updating record of what actions are performed on the system, who performed them, with what privileges, things like that. So event logs also make up a pretty big portion of the records you're going to find on a system. And we're going to go over how to find a lot of network information on a system, because in most cyber incidents, network traffic is involved. And you're going to want to make sure you know what that device is, what all of its various identifiers are, so you can figure out in a packet capture or a network capture what device is what. So for prefetch, we've got a little picture here on the side. Oh, it kicked me out. Get me back in here. What happened?
I don't know. This happened last time with WebEx, where it closes out after half an hour.
Well, that's not good.
Yeah, even though I booked it to be this long. Hold up.
Okay. Well,
You
I
just
guess
give it a sec.
we'll wait for the other guy to come back.
I'll respond to my own email saying that it's. Oh, here we go.
All right.
That was Tosh. Tosh, just stop that. Hold on, let me. Oh, you already are presenting. Okay, this is good. Okay, we're back.
Are we back?
We're back.
All right. So.
Perfect. All right. I'm gonna go back to being muted.
All right. So prefetch, we've got a little demonstration.
Shut up.
Huh?
Sorry, I'm not telling you to shut up. I'm telling somebody across the room who I didn't mute in the meeting.
All right. So prefetch files are stored at the path C Windows prefetch. They come in the format of .pf extension files. And prefetch files are generated whenever a program is run, specifically whenever an exe or a DLL is run on the system. So it is a very good forensic artifact to prove that someone used a program at a given time. Prefetch records the 8 most recent timestamps that it was run, and then past those 8 most recent timestamps, it also records a full list of every or however many times it was run. So you've got 8 of the most recent timestamps you can go back and look at, and then beyond that, you have a total run count for each application. Now, the names, as you can see, are not just the application.exe, it has a little value after it. That value is a proprietary hash algorithm that is used by Microsoft. If you don't know, hashes are mathematical values that are calculated for the content of a file or a text string. It represents the content of that file, and if that file is modified at all in any way, the hash will change. So it's basically a unique identifier for a file or a piece of data. And the hashes that are used specifically for prefetch file names are based on the name of the executable and the path of the executable. So sometimes if you run an application in one folder and then you run the same application with the same name in a different folder, 2 different prefetch files will be generated. So when you're looking through prefetch files, you need to make sure that this prefetch file corresponds to this specific path of executable, which it is listed in the prefetch files once you parse them correctly. I'm going to give you guys an example here in a second of what a prefetch file looks like. Prefetch is on by default on Windows, and 90% of people don't know what prefetch is, and they don't know that they need to turn it off because it's tracking you. The reason the prefetch exists originally is because it helps with load times. Microsoft basically uses it to keep a running list of all of the files that a program needs to boot, and then it just stores those files so that the next time it boots, it doesn't have to completely re-find all of those files. And then continuation of prefetch. This is what they look like when they've been parsed and placed into a viewer program. It will list off the original file name and that file's path. So again, you can have multiple of the same file or program. Or actually, no, that's the bottom image there is what the prefetch files contain. This top image is actually an example of some of the files that are loaded. So this is a screenshot from a lab that I did a few months ago. Um, and you can sometimes use a program's prefetch file. Here we've got 010 editor, which is a hex editor, a different one than the one I was using. And it has a PDF loaded into it. So sometimes, if you get lucky, because it's kind of random the way that Windows stores the cached files, but if you get lucky, you can open a prefetch file and you can see that in the loads for a program, you can see the files that that program opened. So you can see like Notepad opened this file.txt, or you can see Windows Photos opened this file.jpg, things like that. And then, like I was talking about earlier, it stores the most recent run count. You can see that in the last runtime section here. And then it's got a total count of how many times that program has been run beyond those 8. And then, like I was saying, sometimes Windows caches the files that you place into a program, and sometimes it doesn't. So if you open, whatever file.txt in Notepad, there's a chance that it will show up in the loads for a prefetch file, and there's a chance that it might not. So it's not the most consistent of artifacts, but if something is in there, it is a very good indication that that was opened by a user on a system. So registry, like I was saying, registry is this big repository of all of the long-term configurations for a system. It stores information such as your IP addresses, it stores your MAC address, it stores all of the default paths for your users, it stores all of your identifiers for your network cards, it stores um, a running list of all of your installed programs and their uninstalled directories, it stores all of your security configurations. It is a treasure trove for forensic analysts and attackers alike. The most common or most useful registry sections are going to be in C Windows System 32 config. There are some other ones in there other than software system and SAM. Generally, we don't use those. Processing them is usually doesn't yield any forensically useful information, if any. Um, so software contains a running list of programs that are installed system-wide. Critically, it does not keep a record of user-specific programs. That is a different file, which is into user.dat down here. That is user-specific programs and files that have been run recently. So into user.dat is very useful for user-specific stuff, but for system-wide software, you're going to want to use the software hive. The system hive stores most of the configuration information for like the OS and the device itself. That's going to be most of the stuff I was talking about before, like your IP and your MAC and your network card addresses, things like that. And then the SAM hive stores information about the total list of users. It's not like into user.dat that stores user specific information. But the SAM file stores like a list of the usernames of the users, security questions. Sometimes you'll get lucky and it'll show a password in plain text. Usually that doesn't happen on modern systems, but on some of the older systems that run registry, you can find plain text passwords after you parse the SAM file. And the SAM file is also where you get password hashes, which is the primary means for cracking passwords on a system, and it is a very big attack vector. If an attacker gets your SAM file, they have access to your system locally and sometimes remotely if you have the wrong stuff configured. Hive structure. So you notice I referred to the software system and SAM as both files and hives. That is not accidental. They are files that exist on the system. You can go to File Explorer and navigate to the config directory, and you will see the software system and SAM files. However, the registry, these files have their own internal structure, which is called a hive structure, and they have their own paths, kind of. So within the SAM file, you can go to this user SID, this user SID's default installation directory, their user path, their user folder path, and then some details about their user configuration there. So it has that sort of sub path hive structure thing that you aren't able to see in normal files. It sort of goes beyond and deeper than the File Explorer can see. So you need to make sure that you understand that information is visible beyond just what you see in a File Explorer view or a command view. You have to parse those files and then look through the hive structure. And then registry generally gives you the most detailed, the most file by file, byte by byte information on a system. It gives you very intricate details about this file's attribute was changed at this time by this user. It gets you into the very deep configurations of the system, and it can be a very good way to figure out what happened during an attack, because in Windows, basically everything that you do on a system shows up in registry one way or another. If you open up a file, then that file's last access timestamp has been edited in, well, multiple places in the master file table, but we'll get there in a second. But the access time is also updated in registry. So basically everything you do on a system is recorded somewhere in registry. It's just the amount of effort that a forensic investigator is willing to go to get that information that decides whether or not that information is found. And then again, for registry, this is what the Hive structure looks like. You'll notice it is formatted here at the top bar, much like a file path, with, is that a backslash? I think backslash is in between each directory. And then here are what is called the hives, which is the like top level, the root of each of the different registry files. The most common one is local machine, but you can also get information from current user. Current user is user-specific configurations that isn't shown in NT user. NT user is more specifically about the user's desktop and files, whereas current user is more the current user's configurations on the system, like their password requirements and things like that. And then these are some of the most commonly used and most useful registry paths and Hive paths. Software Microsoft Windows NT current version stores a lot of basic information about the system. I can just go there, actually. I can just show you. Here we go. I can just pull it up. Look at me. It's not going to zoom again, is it? Oh, it's not going to zoom. There we go.
I got you. I'm zooming
No, I
too.
got it.
So
I think I get it. Okay. So if I go to, for example, this first one. So this first one right here, current version under Windows NT, it's got a lot of basic information about the system, like what the OS version is, what your basic path is, what the user is that it's registered to, what specific version of Windows it is, installation date, things like that, basic information that you want to catalog during an investigation for legal purposes, especially to make sure that this is what this computer is, this is who it belongs to, stuff like that. And then this next one, so current version run, this is what's going to be referred to as your auto start entries. Your cyber guys have probably heard of these and used them and learned how to deal with them. It is programs that start up on a certain action, usually on the system boot or on a user login. It is a very common means of persistence. It's something that a lot of attackers use to automatically run their backdoors or their beacons or whatever it is to get back onto a system. It's very easy to counteract. You just go into here, and then these are your things that run automatically. There's a couple other paths that have startup artifacts, like run once, which generally people don't use because it only runs it once and then deletes it. Whereas run is a persistent key that continually starts something up every time a user logs in on, or every time the computer is started, depending on the conditions you set. And then you can also run it with specific arguments, like my Avast service has /GUI. You can run a CMD command or a batch file command with different command line arguments, and you can basically just run a script over and over again without having to put in a task, which is neat. Network. Why did I close my registry editor, man? It's been a long day. Okay. So go to the next one. Network list. So here in this window, you don't see a whole lot of useful information, but it's the things that come after it that are quite useful, especially profiles. Profiles is going to be a list of all of your networks. So this is going to be your SSID for the network. And then it's got your date timestamps for when you last connected. You'll notice it's in hexadecimal format for some reason. I don't know particularly why they don't make it human readable, why they make it hexadecimal code, but you can just throw that into an online translator and it should show you a timestamp. Yeah, it's got a lot of useful network information. Sometimes you'll be on a case and you'll want to prove was this guy at this location, and then you can pull up his network list and say, here is this guy connecting to public airport Wi-Fi, this airport at this time. Here's how long the session was. And you can use that to prove whether someone was at a location or not. You can use that to prove or disprove a person's alibi. So this network information right here is very, very useful. Profile list, much the same. Also network information. Um, Also information about. Oh, I know it's not. It's about user profile. Yeah, so it's user profile information. It's about where different users, where their default paths are, things like that. A lot of this information is also available in the HKCU path up here, but local machine also stores a list of all of them for redundancy purposes. It's got information about the state of the user, so if a user is locked out for security reasons, you can change that here. And it's a good way to manipulate things. I closed it again. I'm thinking I'm gonna not post this recording to my LinkedIn actually, because it's gonna make me look not great.
I still
Anyways,
want. We can cut it up. We can cut it up.
we're not gonna do production.
I will
Anyway,
do it. Send it to me.
don't worry about it. Don't worry about it, man. It doesn't matter. We're just learning digital forensics. That's what this is about. This isn't about looks. So the last path I'm going to talk about for registry for the big things is Microsoft Windows Shellbag MRU. Shellbags are another artifact. I didn't place them under the artifacts category because they are pretty much just a registry path. Shellbags are um, shellbags are an artifact that shows if you have opened a directory or a folder in File Explorer. So if I open up my File Explorer and I go to my downloads and I go to the Raven demos folder, this path right here, that is going to show up in my shellbags. This information has to be parsed by a viewer. We can't look at it here, unfortunately, but we do have a way to look at that with some third-party tools. I don't have access to those right now because my infrastructure destroyed itself right before I did this. I really wanted to show off shellbags, but I can't do that because it's a paid software and I don't have a data set for it, unfortunately. But that path, you'll extract that specific. Well, you'll extract the entire system hive, and then this is part of the system hive, and then you'll navigate to that path in the tool parser, and it'll show you all of the various paths that a person has opened in uh, in their File Explorer. It's very useful because a lot of standard users use File Explorer to open their files. For example, one of the cases I worked on last semester, I won't share the details for privacy reasons, but it was a case about a suspected bad actor within an organization. The client came to us and said, we think this person accessed these resources, figure out whether they did or not. And so one of the first things we went to was shellbags because this person was a non-technical user and they were pretty much just using the laptop to store like personal files as well as work stuff. It was issued to them by their employer. So we went through and we looked at all of the paths they had opened and what times they were. We noticed that they opened sensitive network resources for that organization, but the timestamps that it showed were prior to the cutoff period that we were given after that access was supposed to have been revoked. So we were able to, with the shellbags artifact, not disprove, because in digital forensics sometimes stuff isn't recorded right, but to give at least a little bit of extra credence to the defendant's claim that they did not access those resources because they had accessed them in File Explorer previously, but the shellbags showed they had not accessed them recently, or at least via File Explorer. Event logs, like I said, they are more of a running record than the registry. They keep a common listing of everything that a system does, both in the background and in terms of user specific actions. I see you laughing over there. Don't you laugh at me. Anyway, they're stored in .evtx structured files. You can open them in third-party viewers like Excel. Generally, that's not advisable because the formatting is funky. Usually, most people just use the built-in Windows log aggregator, the event log viewer. They're stored at the path C Windows System 32 WinEVT logs. You can specify alternate paths to store event logs. So if you go to a system for an incident response operation and there's not logs in the WinEVT logs path, don't panic. You can check the configurations to figure out where they have been stored. Um, so application specific logs. There's two different kinds of logs. Primarily, there is the system logs for the running system, just the main computer by itself, like Windows based basic operations, the OS basically. The OS keeps a record of its own logs, and then all of the third party apps and programs that you run generally have their own sections of logs that they store. Attackers will very often clear and then disable event logs to help cover their tracks during a cyber incident, but that is mostly for the security and system logs. When it comes to application specific logs, they are very often overlooked. So if someone accesses a FileZilla FTP server, um, they'll usually stop the system and security logs to stop the remote logon from showing up. But then if you go and look at the Windows event logs that are stored under FileZilla, oh look, there's access to this thing at this time, and we've got the guy now. Um, this is a basic idea of what each record looks like. It has a keyword section that sort of summarizes what the event looked like. It has the date and time that it happened. It's got the source file, so these are all from the security log. The main thing is the event ID. Event IDs are used to identify what type of event it is and what happened in that event. There's a giant listing on Microsoft's site that has the correlations of this event ID means this. One thing to note is that event IDs are not set in stone. Event IDs can mean like three different things. Like the event ID 10,000 that we're going to go over in a second, it can mean a network session start, it can mean a driver installation, or it can mean a DCOM launch failure. So you have to use context. You can't just use event IDs by themselves to filter. I don't know why Microsoft did that instead of just adding more event IDs. That would make more sense to me, but that's how it works. And then at the end, we've got the task category, which is sort of a more general version of the keyword section. It sort of tells you like what domain this falls under. And then again, for event logs, this is a general idea of what each event log looks like. This is the general tab. The details tab shows more of the structured like background information and things. Specifically, this is what a log looks like when someone tries to remotely log into a computer and fails. Eli is probably going to laugh because I told him about this while I was making this presentation. This is a lab from my laptop of a person trying to remote into my laptop. Um, but luckily, I had disabled the guest account before he did. Logon type 3 is a remote logon through RDP. Well, it's a remote logon of some type. Usually it's through RDP, sometimes it's through third party apps. But if someone tries to connect remotely and it fails, it will record the IP address and the port, which is very useful information if you're trying to track where an attacker is coming from on the network. So, yeah, this is what a failed remote logon looks like. Don't be like me. So configurations for event logs. They can change very drastically. Different organizations have different policies, different sysadmins implement their log aggregation in very different ways. So a lot of people will just leave the default configurations for event logs, which is fine for most purposes. But then when an attacker gets into some third party app thing that doesn't have default event logging, then you're kind of out of luck, which is unfortunate. But you also can't just leave all logs turned on because logs take up space on a system and you have to cycle logs out. You can't just keep storing terabytes and terabytes and terabytes of logs that build up very quickly for relatively short amounts of time. So you have to pick and choose which specific parts of your organization need to be logged, which components need to have what levels of logging. You can exclude logs that are only informational and not errors or warnings. Just be careful about how you configure logs, and when you're going in to do an investigation on a system, keep that in mind that different configurations for log auditing will lead to different visibility of what happened on a system. Usually not in your favor, unfortunately. Event logs make up most of a timeline rebuild besides registry and MFT modifications. So a lot of your more important events like user logons and session starts and service starts and stops, those will all be recorded in the event logs. Those are all things that will be aggregated from your event logs by forensic tools and suites, and it will be placed into a timeline for you to look at. So when you go in and make your timeline in your autopsy or Axiom, event logs is a pretty big portion of where it's pulling from. So, network information. You can get a lot of information about a network or about the system specific network configurations from event logs, from your registry, and also from this thing called System Resource Use Monitor, or SRUM. That's also sometimes referred to as SRUDB. Um, which I will give a demonstration over what that is here in a second, but it's basically a running record of what programs on the system use what resources, specifically power resources, network resources, and CPU resources. So you can use that record to look at, okay, so this is Google Chrome. It used this many bytes outgoing off of the network at this time. That means it is probably exfiltrating data of some sort, or it's streaming. Um, so the system resource usage monitor is a very good way to figure out what programs are doing the most activity at what times. Unfortunately, it's not quite as specific in terms of what that action is. Oop, nope. Don't go on yet. No. 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 Okay, we're good. So anti-forensic techniques. I'm going to go into that. If an attacker is trying to get to you from a network, from a remote device that's not in your local area, there are a lot of things they can do to cover up what their device is and where it's coming from. They can use VPNs, they can use IP piggybackers, they can use um, IP maskers. They can also bounce off of various devices that are in your network if they have access to those. So you need to be aware that not every IP address you see is going to be the actual IP address of the person that's trying to get to you. It could be the address of a server they're using to attack. It could be the IP address of outside their outside router. It could be a number of things. So every connection that you see is not 100% the connection that is happening. It might just be what the system sees as the connection. It can only see from itself to the next link in the chain of the network. It cannot see the entire chain, unfortunately. That's just how networking works. So network information, a lot of your information is going to come from event logs, like I was talking about before. Event ID 10,000, it can mean a few different things. But one of the things that it means is a network session initiation. So when someone gets onto a network or plugs in an Ethernet cable, sometimes if your logging is configured well, it will log that as an event ID 10,000. And then the session stop is 10,001. So if you have a 10,000 event and a 10,001 event, you can figure out how long the session between those two was and how long someone was on a network for. Um, 1,000 or 8,001, 8,002, and 8,003 are, I believe, different categories of Wi-Fi networks that are being logged into. I'm not 100% sure. I don't see those event logs very often, to be honest. Really, the 10,000 and 10,001 ones we also don't see very much. So I would not rely on those. But the big thing is going to be RDP logs. So when people are trying to attack your device remotely, much of what they're going to be doing is through remote desktop, which is RDP. It's a way for a Windows machine, or well, it doesn't have to be a Windows machine, some other device, desktop device, to log into a Windows device that is hosting an RDP server. And um, the logs that are configured by default in RDP are pretty decent. It shows all of the session information, it shows the IP, session time, session closeout, session permissions. It shows all of that by default without having to change anything. So you can get a lot of pretty good forensically valuable information from remote desktop logs in the event logs viewer from Windows. Packet captures are extremely useful if you can get them. The thing is that a lot of systems don't get them. Um, if an incident happens, you want to make sure that you have your network stuff configured to capture the network traffic that was going during that time, during the time of the incident. A lot of system administrators keep logs for a couple weeks so that they can go back and look at them and save those logs, and then they auto cycle out if those logs are not saved by the end of those 2 week periods. Packet captures are essentially every bit of traffic that you send across a network is in what is called a packet. It is a set of data that is encapsulated in routing information and flags and uh, other stuff that the system needs to figure out where this thing is going and what it needs to send to get it to where it needs to go. And so those packets are sent in streams, in these big chunks sometimes across a network. And if you can get a saved log of those packets, you can pry apart each one of those packets and look at what those packets look like. And I have a demonstration of what network packets look like that I set up last night at like 2 a.m. Wireshark. So this is a PCAP that I took from a forensic scenario many years ago in 2009. But it does a good job of showing what a lot of traffic from a usual user would look like. So first, we're going to open it in Wireshark. It's going to take a bit to load because it's a big data set. Wireshark is used very commonly. It's probably the most common network analysis tool. It's what people know of. It's what people go to by default when they first hear, oh, we're doing network analysis. All right, let me boot up Wireshark. And Wireshark is a great tool if you want to just see generally what's happening in a packet capture. But the problem with Wireshark is that it keeps everything at a very high level. It shows very detailed information, but it doesn't really break it down for you in a way that a person can natively understand, if that makes sense. If you do a lot of work with Wireshark, then you can kind of see what's going on. You can tell from the various packet colors and identifications and the protocols and stuff. You can tell what's going on from that information, but it doesn't really show you the contents, and it's pretty bad for getting an idea of what specifically is happening in the package that you're looking at, which is where Network Miner comes in, which we're gonna get up in a second as well. Um, but the thing with Network Miner is that it doesn't show you the raw packet capture at all. You can see all of the various connections. You can see the files it's sent across. You can see logins, you can see session information, endpoints, DNS resolutions, a whole lot of useful information, but it doesn't show you the actual raw packet stream. And unfortunately, this is something we're going to go over in session two a lot, but I'll cover it now for a little bit. If you're in court testifying about a case in digital forensics, the lawyer is going to want you to prove this is what this thing is. Not with just like this tool says this happened. No, he's going to want you to say, show me where in this packet you got this information. And Network Miner can't really do that. Wireshark is really good at doing that, but it's not good at doing all of the practical stuff. So you kind of have to use a mix of both tools, both kinds of tools. This is really taking a long time to load. I'm really trying to stall.
No, it's good. Okay. Does anybody have any sorry, I need to unmute in Discord too real quick. Uh while we're stalling to wait for this packet capture to open, does anybody have any big questions or anything so far? I know it's been a lot and good bit of info. Um does anybody have any questions? No stupid questions. I'm not saying that you can't ask a stupid question. I'm saying no questions are stupid questions. Anybody from here? Anybody from online? Uh, uh,
Let me see if I can open this in Network Miner in the background. Start getting that going.
any questions for John in specific? What's your favorite color, John?
Oh,
Blue. Um, yeah, do you guys want to know anything about like digital forensics as a job? I know there's some specific questions we got from the form submission that I'm gonna go over in a bit, but do you guys want to like want any information about what it's like to be an investigator? Do you want to know like what you gotta do? Do you want to know good schools? What you want?
what's your favorite part of working in digital forensics outside of the like, oh, I'm catching the bad guy?
Here,
Like,
let me hand the mic over to him because he just asked the question. Hold up. This
sorry, John. I said, what's your favorite part of working in digital forensics besides the like, catching the bad guy, like, power fantasy?
Well, I was gonna say the catching the bad guy power fantasy. You kind of got me there. Other than that, my favorite thing, I'm a very big puzzle guy. I like putting together like what happened and figuring out from little clues and breadcrumbs, figuring out what happened. So I think that being able to take things like this massive Wireshark capture that finally loaded, and look at those different packets and what they're sending, and gain as much information as I can out of that. And then also, um, it's just a big, it's just a big field. There's a lot to learn, a lot to know, a lot to figure out. You're always learning more. I feel like that's kind of what everyone says about their field, but it's especially true in digital forensics. There's always new technologies coming out. There's always new techniques criminals are learning to figure out how to stop you and how to get around your techniques to find them. So it's kind of this cat and mouse game of like, well, okay, you've got this new tool that evades my current techniques, so how am I going to make a new tool that evades your new tool? Things like that. That is very entertaining to me. I like that.
awesome. Thank you.
Yeah, of course. So, this is what everyone watching at home, I promise it was going to be better than this. All right, let me go log back in. The WebEx closed again. We don't like it. We don't like it. Okay, let me find this link. Open in WebEx. If I do post this to my socials, if you're a DF guy, please hire me. I know I don't really seem like I know what I'm talking about, but um, I do. I'm just not good at public speaking. All right, we're
Oh
back.
my gosh.
We're back.
I love WebEx so much. WebEx is so cool, guys.
It's made by Cisco. Don't trust Cisco. We never trust Cisco.
Cisco wants too much money. Well, hey, at least you're engaged enough. Thank you for that. Of course, Quinn is cooking.
All right.
Okay, maybe. Okay. Do I have to? I probably do.
Are we back? I think we're back now.
Yeah, yeah. It's chill.
Let me share again.
You know what didn't fail? Discord.
You want me to go on Discord? I can go on Discord if you want. No?
No,
Okay.
it's probably chill. All right. Sorry, y'all. This
All
is
right.
just a reoccurring issue. We can do this tomorrow for on the Discord.
Okay, yeah. So tomorrow we'll do the session on Discord because that's going to be probably a longer session. At least definitely during the activity session or the activity section, and I want to be available for people that have questions. Because I know that people are definitely going to have questions, whether they actually ask me them or not, about tomorrow's activity. So, this is what a Wireshark output looks like. Like I was saying, it has a lot of raw information that is very useful in terms of like you're in court, lawyer asks you, can you prove this guy sent this thing and where did he send it? This is the kind of thing you would want to show him. And of course, a lawyer's not going to understand that and you're going to have to explain it to him because he's stupid. That's okay. Um, but the information you can glean from Wireshark captures, or Wireshark specifically looking at packet captures, is not quite as useful as the information you would get from something like Network Miner, which has loaded now. So in Network Miner, you've got all these different tabs of information that it has parsed out. So it shows the different hosts and sessions with those hosts. For example, this image for this forensic scenario, you can see this guy was going to a bunch of news sites. He was going to MSN, ABC, Al Jazeera, Washington Post. So that kind of information is stuff you're going to want to. That's very practical. That's very useful in an investigation to document. This is this guy's habits. This is where he likes to go. Um, and if it's often the kind of thing where people who are storing illicit content on their computers will, well, they won't store them on their computers, but if you have a network capture somehow of that network, if they store network traffic, which is pretty rare for someone that stores illicit content, but if you somehow get a packet capture, you can see the various sites that he visited, even if it's not stored locally on his computer. Files. This is also very, very useful. You can see all of the various files that were sent across a network. Now, most of this is going to be background stuff. Most of this is going to be websites sending cookie sheets and chunks of random data and sections of things that we don't really need in forensics. But other things like this downloads.whatever.txt that could be useful. That could be something that a user went out to a website and downloaded this file, and now that file infected him. So we can use that as like, oh, this is where this guy got it. This is the timestamp of when he got it. This is the IP address of the server that gave it to him. This is where it ended up on his local machine. This is the type of packet that it sent. So being able to see what files were transferred across the network is very, very useful in a forensic context. And especially being able to see images is very useful. Um, so this kind of stuff, again, a lot of it is background information. A lot of it is stuff that you're not going to be able to see, or that you would be able to see anywhere. Unlike a browser, it's just like random like website features and things like that. But others of it is like, this is user content. These are pictures that were sent across a network. These are things that a person probably sent intentionally to a friend or something like that. Um, so being able to look at the images and seeing the thumbnails of those images is very useful. Messages, this generally doesn't capture that much. It does capture SMTP traffic, which if you don't know, SMTP, Simple Mail Transfer Protocol, it is emails. Um, People don't really use emails that much anymore. They do for official communications, but um, for like private stuff, for cases where you're going to be gonna want to be finding communications between conspirators or victim and suspect, you're generally not going to see that much in this pane. It can be useful, but usually not that much. Credentials, similar sort of thing. It stores cookies and session tokens, things like that. One of the things that they train us on here at Champlain is login stealing. So if we have a user who we can't get access to their cloud account, we don't know their password, we can't get Google to give us a backdoor in. If we have an image that was taken recently enough of a suspect computer, we can get that guy's login token, and if he doesn't have multi-factor authentication, we can inject that login token and get access to his Google Drive. And that's the sort of thing you would want to get a special warrant for, things like that. We'll cover warrants and stuff in tomorrow's session. But generally, with current security practices, with multi-factor and with cookie expiration, you're not going to get that much useful information from a credentials window, unfortunately. Modern security practices have made most of this basically useless. Sessions, a lot of this information is going to be very similar to the host session or host section. It's just that it shows the specific times and the connections between what device to what other device. Um, and it shows it in more of a chronological format. The hosts, I don't think, is really chronological. It might be like the first time it was used or the last time it was used, but it's not particularly chronological. Whereas the sessions area is chronological. So that can be an assist in an investigation to rebuild a timeline of network traffic. DNS records, again, very similar thing. It shows networks, or not networks, websites that were connected to, and the network addresses that are mapped to it. This could be useful in some specific scenarios, like a DNS poisoning attack, where you want to figure out exactly what DNS records go where. Generally, for the kind of forensics that I do, I don't really use this tab all that much. It's simply not something that we find a lot of information from. Parameters, I have no idea what most of this is. A lot of this is to deal with web packets and server responses and things like that. I have done a little bit of server development for my capstone project. A little bit of like Python socket response giving, but most of this is stuff I don't know very much about. It seems somewhat useful because it's got, responses and requests to servers. So if you've got an attacker that's trying to send injection traffic to a server, you can look at the request to that server on the server's network, and you can see in these request packets, you can see where the attacker is trying to do that injection. So that would be the kind of thing that would be very useful in a cyber incident investigation, not so much in a criminal investigation. And keywords, this is very useful. So most forensics tools have a field where you can do a keyword search or pretty much just a regular search function. They just use the term keyword search because it's kind of the industry term. But it's where you type in a keyword that you want to look for, a word that you want to find instances of, and it will pop up. So for example, in this case, if we want to look for, what was one of the names that was in the messages? Pat Magoo. So we'll look up Magoo as the keyword. Hello? Yeah, there we go. And then we'll reload the case files. And I forgot it's going to take like forever. But anyway, if you want to look for keywords, there we go. Start popping up. you can put a keyword in this field here and then add it, and then you'll reload your files, and it'll start popping up packets that have that keyword in them. So if you're wanting to look for a specific username or a specific website subpage that you can't really figure out from any of these other tabs, you can use the keyword search to look through them. It's a very, very useful feature in basically every forensic suite. Keyword searches are make or break, and we will talk about the differences between keyword searches on different tools here in a bit. Anyway, so that is the difference between Wireshark and Network Miner. That is how you look at PCAP files, network traffic captures. It's pretty sick, but also, again, like I was saying, it's not something you see a whole lot of. You don't usually get a packet capture in an investigation. It's a nice thing to have, but at least on the criminal side of things, on the law enforcement side of things, you don't get packet captures very often, unfortunately. So, back on track. The other main place you get a lot of network information from, and really the main source, is your registry. So I think I went to all these earlier, so I'm not gonna put you guys through that again. But all these different paths here at the local machine registry in the system software hives, you're gonna see a lot of information about the different network interfaces, the different networks that you've connected to, and their SSIDs. You're gonna see a lot of information about connections that have been made to and from that device, mostly connections that you make to a network in the registry. Tools. Tools are also something that is very, very important in forensics. A lot of forensic technicians rely very heavily on their tools. They just trust the tool automatically. That is a very bad idea. You need to use the tool to find things and then follow up on what that tool tells you and verify it. So much like I was talking about with the Wireshark thing, um, well, Wireshark versus Network Miner. If you see Network Miner pulls this image out, you can't just say Network Miner pulled this image and then submit that to a court. They're not going to take it. The jury is not going to be beyond a shadow of a reasonable doubt on that. You have to pull up the raw data, which is what Wireshark shows, so you can just show a Wireshark output if that's easier for you. But show the raw data and show the source of where you got that raw data to a court and explain what is contained in that raw data. So you can't just trust the tool to do everything for you. With that said, tools are very useful and they're something that you're going to have to use in digital forensics. So I've got a few different tools here. There are 4 different things. It's not really a direct apples to apples comparison. Each tool that I've listed here is for a different purpose, and you're going to use them for different things throughout a forensic career. These are some of the most common ones you're going to see. The big one is FTK Imager. Everyone that has done forensic work knows what FTK Imager is. It's the program that basically every law enforcement agency that does digital forensics uses. For a few reasons. It's sort of the industry standard. It's what everyone uses sort of de facto. It's very fast. It is very well optimized for what it does. It is probably the fastest imaging tool I've used. At least in terms of imaging entire volumes, unless you're picking out specific artifacts. And it also is very good at taking like lesser known forensic formats from third-party tools and translating them into more usable forensic formats. Unfortunately, because it is so well known, a lot of people know how to get around FTK and the way that it looks at images, the way that it reads data off of a computer. A lot of attackers and adversaries know how to get around FTK Imager. One of the things that Eli might remember is when we went to a conference called GERCON in Grand Rapids. One of the guys that we ended up talking to was a digital forensic specialist from the FBI. And what he told us is that he uses FTK Imager at work all the time, and people are constantly figuring out ways to make FTK confused and to make it read data in a weird way. So Yeah, FTK is great at what it does, but it is also very well known and very easy to hide from. It doesn't really have artifact analysis capabilities. It is very good at imaging and it is very good at displaying data on an image, but it doesn't really help you do analysis all that much. You can extract things with it. It doesn't help all that much in terms of your job as an analyst. Axiom is the kind of thing that you're going to want to use for analysis. It is a full function forensic suite, so it's capable of extraction, imaging, image verification, artifact analysis, identification, all that neat stuff. Magnet Axiom is great. It is an awesome tool. It is also a paid software, so it's something that you guys will not be able to use for the lab, unfortunately. However, I do have permission to show our remote access to it. So we're gonna go over here. Can you guys see that, Eli? Can you see that? Oh,
Can you? Yes.
okay. So this is what an Axiom case dashboard looks like, and then this is what the artifact specific thing looks like. It'll give you a lot of information about the device off the bat, and then it will also break down some of the more specific artifacts. This case does not have all that much artifact or all that many artifacts involved in it, because it's a pretty small image that I was processing just for demonstration purposes, but it gives you a fair amount of information about it and about the size, where it resides on the disk, things like that. And yeah, that's what Axiom looks like. So, let's go back. Last two tools, Arsenal Image Mounter. I do not have a demo for this. I did have a demo for this, but it stopped working today, unfortunately. Arsenal Image Mounter is um, very useful for taking images that are not mounted in FTK, because FTK mounts things very unstably, and it is very good at making them stable and mounting them in a way that you can access them and not modify them. So Arsenal Image Mounter is what you're going to want to use when you have an image that you want to go through and you want to mount it onto your system and be able to read it safely. Autopsy is my favorite forensic software. It's also kind of a toxic relationship. It is very well rounded. It handles a lot of things for you. I've used it in basically every case that I've done for school in the past 4 years. It is a very useful tool and it does a lot of things very well. Unfortunately, when you run the ingest modules, there's like a 50% chance that it will just break and crash and sometimes even kill your entire computer. Um, and it almost never works on the first time that you run them, so you'll have to run them multiple times. Unfortunate. So, the lightning round. This is unfortunately where we're going to spend a lot of the time, even though it's a lightning round. So, volume shadow copy or VSS. It's a lot like system restore, if you know what that is. It's an automatic backup that Windows does. It stores a copy in a compressed format of all of the files on your system. And volume shadow is a very good artifact for if someone deletes something, you can go back to the volume shadow copy that was taken like a week prior, and then pull that deleted data off of the stored shadow copy, because it's basically just a compressed folder. Link files are shortcuts. So if you have a shortcut like on your desktop to a game or a browser or something, that's what a link file is. That's the shortcut. And you can parse those link files and it will show you the original file that it linked to, and they are not deleted when the original file is deleted. So if you have a link file to a browser or something and you delete the browser, that link file will stay, it will remain, and you can parse that and look for the original name of the file, so you can use that to sort of prove that a program was run or that a program existed on a system. Jump lists are very similar to link files. They are basically linked lists of link files that create these long chains of recently accessed documents. So, for example, if I exit out, I right click on Notepad, all of these documents, that is taken from a jump list. So, all of those link files, Each one of these is a link file that is stored in my computer's app data directory, and it links all of those together and puts them right here so that I can access them quickly. Recycle bin. So when you put an item into recycle bin, it doesn't actually delete it. It actually separates the raw content or $R files from the information about that file, which is the $I file. And then it hashes up both of the names so that you can't tell what it is without being or without restoring the file. So when you restore a file, all it does is it recombines the $I and $R files. This is also very useful for if someone has put files in the recycle bin, you can use those to recover, and you can also parse the recycle bin. So if someone has deleted part of the data that's in a $R file to try and corrupt it, you can still find the original file name and get some of the content back by parsing it with some third-party tools. And yeah, that's recycle bin. File slack. So I don't know how well you guys know file structure. Again, I'm kind of doing a beginner-oriented sort of thing as much as I can. I know I'm going kind of fast, but file
Just fire
slack.
through it.
Yeah, I'm trying, man. I'm trying not to take up y'all's time because we got an activity after this. But this is the last like slide before the activity. Okay, so this is the last bit. File slack is when a file is created on a disk, it takes up a certain amount of sectors on that disk, and so when a file is deleted off of that disk, it's not actually like removed. It's just that section of the disk is marked as free and new files can be overwritten onto it. Sometimes when a new file is overwritten onto that empty space, it's smaller than the original file. And so that the new file does not cover over parts of the last sectors of that old file, but the remaining content in that or in the empty space of the last sector of that new file that you have, that would normally be blank if it was written to a blank part of the disk. Instead, it contains the remaining information from the last file that was there, or the file slack. Um, a lot of the time, it's not really useful. It contains random like background information files or things, but sometimes it can include information from deleted files that were intentionally deleted, and you can use it to get out some guy's like child porn that he had on his computer. Generally, not that useful, but again, it is an option for an artifact. Remote desktop session reconstruction. This is probably my least favorite artifact of all ever to work with, period. It sucks and is miserable. Windows caches on a computer that makes a remote desktop connection to another computer. It caches like screenshots, like individual frames of the remote desktop connection from the connecting computer's perspective. And then it takes those frames, those individual frames, it cuts them into grids of like hundreds of squares and then caches them. And there are these really awful forensic programs that exist to reconstruct them literally like a jigsaw puzzle. Like you take these little like grid squares and put them back together like a jigsaw puzzle to make a single frame of a single second of a single remote desktop session. It is probably the least effective juice for the squeeze artifact I've ever seen in my life. But at the same time, sometimes you can catch a dude running a PowerShell command, and it's really useful. But, the instances where that's useful are few and far between. Browser databases. So a lot of browsers store their information and a lot of their information, like basically all of their information in this one directory. It's stored where I have it written down somewhere. It's stored in your C user app data, your local app data, and then it's going to have the browser provider. So for like Chrome, it'd be Google. For Firefox, it'd be Mozilla / the browser name. So for Chrome, it'd be Chrome, Firefox / user data / default. And then in that folder, you will have a whole bunch of SQLite formatted databases. And in those databases, there's things like your user history. So this history file, which is one of the big ones, stores every website that you have visited since you installed that browser, including in incognito mode. That does not matter. Incognito mode does not actually protect you from anything. It just marks off like a 1 or a 0 in those fields. It doesn't stop you from seeing anything in the SQLite database. It will store logins that you have stored. It will store credit cards. It will store your address. It will store anything that your browser that you've typed into your browser. It will type, or it will store basically all of the information you have given to your browser and you have looked at in your browser will be in those databases. It is a very soft target. It does not have any kind of encryption or security besides NTFS file level permissions, which can be overridden. And basically all spyware that is looking to harvest credentials will go there first. It will go to these browser directories and it will harvest credentials from these various databases from your history and your user credential or your session tokens and cookies, things like that. Thumbcache and thumbs.db. I am going to do a demonstration for this one. I'm trying to be fast, Eli. Here we go. I'm going to do a demonstration for this one because it's a very important artifact and it's one of the most useful ones that I've seen. It's also very low effort. So, Thumbcache is a thing that is somewhat recent. Before that, it was prep-ended by thumbs.db. It's basically whenever you open a file, or an image file specifically, it has to be an image file. Whenever you open an image file on a system, it will store a thumbnail of that image. And the thumbnail is basically a smaller, more compressed version of the image that you have opened. So, these massive databases called thumb caches exist for every file you have opened on a system, which means if you delete a file or an image that you have that you already opened on a system, it will still stay in your thumb cache. So if a guy opens up some illicit material on his computer and then deletes it because he doesn't want people to see it, you can go into the thumb cache viewer, parse the thumb cache files out like I have here, and then off to the side it will show you these thumbnails. There are different sizes of thumbnails. If I go into this folder here, you'll notice that each one has an underscore and then a number. That is the pixel size of the thumbnail image itself. Usually the bigger images are easier to see, so you're going to want to look at the larger numbers for caches. So you can look at here, this is the thumbnail cache for my computer. It's got some screenshots I took for labs, and these are all screenshots that don't exist on my computer anymore. So if this was, something illicit that I didn't want investigators to see, the investigators could pull up my thumb cache and still see that it's there. It's a very, very useful artifact, and I use it a lot. MFT entries. I am not going to go into the details of what the master file table is because it's really complicated, but basically master file table is a record of every file that has existed on the system ever. And every file that has existed on the system ever is given a unique MFT identifier. So even though the MFT does delete records when files are deleted, it does not update that blank ID. So if a file that was given the MFT ID of 49 is deleted, you can still see there is a blank between 48 and 50. You won't be able to see what item 49 was. I mean, you probably can with other different artifacts, but with the MFT itself, it does not show the deleted file. But it's a good way to see, like, this is the item that was here, or these are the items that are here. There was something in between them. If you can find a mention of an MFT item with this name elsewhere on the system in some cached file, which is pretty common, then you can figure out what item was there. It's very convoluted and annoying to deal with from a forensic perspective, and I can't get into the specifics because I'm taking too long already, but it is a useful artifact to know. Metadata. If you guys don't know, metadata is basically information about a file that is not the content itself. So it's like on a document file, if you're opening like a Google Docs file or a Word file, it'll have like the author name, the date it was created, things like that. That is all metadata. That is all information that is not the content that is stored about the file anyway. It's very useful if people actually fill out the metadata. For example, the BTK bind torture kill killer was caught using a document that had metadata that listed the church he was a part of, and they went to that church and figured out who was on the board, and they found him that way. Another thing about metadata, I'm going to do another demonstration. I'll make it fast. Another thing about metadata is if you take a file that has metadata on it, this is a file I took years and years ago. Pretty unassuming, right? You can't really gain that much of an idea about what's in the file from the information in the actual visible pixels. But if we go to our EXIF viewer, this funny little field here has your GPS information. So I can just hit open it in Google Maps, and there's the exact street that I took. That I took the picture on. Teehee. So metadata can be very, very useful if you have geotagging enabled, which a lot of modern iPhones and things like that do have it enabled by default. So it's a very useful artifact to look through metadata. And a lot of tools like Autopsy have modules that will automatically process metadata for you. It's not really something that you have to look through manually. And then we're also going to go over some concepts in digital forensics that aren't necessarily artifacts themselves. Steganography is the process of hiding data in an image file. So you can do that either by making like a couple pixels darker and then running it through color scanners to see what the darker pixels spell out that aren't really that visible. You can put information in the metadata of an image file. That's considered steganography. You can also hide messages in image files by putting data in between the header and the footer that we talked about earlier. Yeah, that's a basic overview of steganography. Little Endian versus Big Endian. This is another thing with hex editors and bytecode manipulation. Endianness refers to the direction that bytecode is read in. So Little Endian is when you read least significant bit to most significant bit, which is a really complicated sounding way of saying you read from the right to the left and not the left to the right in terms of the bytes as they appear on screen. So if I open up, I have another demonstration. If I open up the program for Network Miner in a hex editor, if I look at the word this, the hexadecimal representation of the word this, it's currently being read in Big Endian. So the Big Endian value of this text is 1/4. It's that value. That's what the numerical representation of these bytes is. If I change it to Little Endian down here, the numerical value changes as well. That's because it's being read instead of being read from 54, 68, 69, 73 like it is in Big Endian, Little Endian reads 73, 69, 68, 54. And it also reads the bytes left to right individually, but the actual like long string, it reads the total string of bytes right to left. So instead of reading 3796 here, it would read 7369. So yeah, Endianness definitely changes how you look at a file. It changes how a computer understands what a file says, and it can very easily trip you up in forensic analysis if you're not careful. Unallocated versus unpartitioned space. So unallocated space is space that is within a logical volume, which is just a partition or a specific section of a hard disk that has been told you are part of this volume, you are part of this area, you can use this much space within this area to store files. Unallocated space is space within a partition that is simply not being used at the time, but it can be used by just placing a new file there. Unpartitioned space is space that is not within a partition.
There goes a connection.
Oh,
John, you good? We hear you, John?
I think we're good.
Good. I think that was just you getting cooked.
Was that me?
It was either you or us getting
I
cooked.
think it was you, because the other person in the call did not go away on my screen, but you did.
Okay.
Okay, we're good.
Well,
So,
all right.
Unallocated space is space that is within a partition but is not actively being used. It can be used once a file is assigned to it. Unpartitioned space is space on a disk that is not assigned to a partition, which means that it cannot be used until it is assigned to a logical volume or a partition. The difference between this is important for logical versus physical imaging. Logical imaging only takes one partition or information within a partition, whereas physical imaging takes all data on the disk. So, logical imaging does not account for unpartitioned space. Physical imaging does account for unpartitioned space. So there is some data that can be stored in there if you repartition a disk that you're missing if you get a logical image instead of a physical image. Oh, go back. NCFS. NCFS is Windows's primary file system that they use for Windows. It's the thing that they use to run their OS off of. It has a lot of benefits like file level permissions and a lot of efficiency and compression, whereas FAT file systems are file systems that exist on flash drives and sometimes Linux machines. They kind of do their own thing now, but they sometimes use FAT. It's shorter shelf life than NTFS, so it's worse for storing long term data, but it is more universally acceptable. You can use them on Mac, Linux, or Windows devices. So when you are storing data in different volumes, take into account the differences between different file systems. NTFS is better for long term and for only on Windows. FAT is better for universality. Cracking passwords and encryption. Sometimes you will encounter problems in forensics where you cannot log into a device that you have imaged. And sometimes you can crack the passwords on that. I have done that many a time. As long as you have the proper warrants and proper permission to do or permission to get in that way. Sometimes it's not advisable. Sometimes organizations have like a minimum password limit of like 12 characters with special characters, in which case you're not going to crack it. It doesn't matter. Unless you have the craziest dictionary list you've ever seen, it's not going to matter. You're not going to crack it. But in some cases where it's a shorter password, it can be viable. So if you get locked out of a device and you don't know the password and you don't have the option to boot into a forensic OS and get past that password, cracking can be a viable option. In terms of encryption, depends on the type of encryption. Some of the weaker encryption, like BitLocker, can be bypassed or cracked. I have cracked BitLocker before if you use a weak password. Whereas if you use like Apple's M2, M5, whatever they're doing now, Apple's special chip encryption, you're basically fucked if you don't have the admin password to it. So getting past encryption and passwords is possible in certain cases, but it's not advisable in most cases. Data destruction methods. Generally, you can destroy data either physically or programmatically. Some examples of physical data destruction would be you smash the hard drive with a hammer, you throw it into a river, or you drill a hole through it. Physical data destruction, if you do it right, is the most effective way to guarantee data destruction, but a lot of people don't do it right. So, for example, if you throw a hard drive into a river, it's hermetically sealed, which means it won't get flooded with water for a few days. So if you throw a hard drive into a river because you like stored pictures of a murdered woman on it, you can still get that back for a couple days, and it has happened many times in many cases. Drilling a hole through it, you can recover information from the rest of the platter still, as long as you read it with the right hardware. Programmatic data destruction, you can overwrite it with zeros. Technically, that's forensically recoverable up to like 14 passes, but generally the DoD standard is 3 passes of completely overwriting data with zeros. Another way to programmatically erase data is to reformat your drives, which is not advisable because we can recover that up to like a bunch of reformats. So people will reformat to destroy data, but then we'll be able to get it back. So when people talk about data destruction and like burning your hard drives and stuff, don't believe everything you see in movies, because a lot of the time when you think your hard drive is completely cooked and destroyed just because it can't start, that doesn't matter. We can just transplant the platter onto a different hard drive chassis. It doesn't matter. Time stomping. Timestamps are very critical for forensic analysis, and a lot of a lot of attackers know that. So they will intentionally modify timestamps. They will see I took this data and I accessed it when I shouldn't have, so I'm going to take this timestamp that shows that I accessed it at this time, and I'm going to make the timestamp like 16,000 years in the future, so you can't tell who accessed it when. That is possible. It also leaves evidence everywhere. So if someone modifies a timestamp by time stomping, yes, that file's timestamp will be messed up, but there will also be a record everywhere else on the system of the thing that you used to do the time stomping. There is a process in forensics generally, which is called Locard's exchange principle, I think it is, which is the idea that wherever you touch something, evidence is left. And that is very much the case in computer forensics. You can do time stomping and you can mess up timestamps, but you will leave records elsewhere that you did that. Okay, that's the lightning round over ish. So we're gonna go to the fun part, which is you guys doing things and me not talking because my voice hurts. I'm sick. Um, so first one's gonna be file carving. You're gonna be file carving specifically a JPEG file. Second one, we're gonna be taking some prefetch files. I do have a whole directory of them, not just one. And then the third one, we're gonna be looking through some event logs. Man, those of you on recording, it's not working out.
Presentation.
All
I
right.
can go to that slide. But yeah. Yeah. I'm just gonna go down here. I'm gonna go to John's stuff. Make him admin again. I mean, you can continue. Actually, wait, we don't have our other person, but
I'm pretty much done talking. Pretty much
yeah,
the only
yeah,
thing I got left is the scenario, and then if you guys have questions, you can yell them out to me. You can DM me, whatever.
or me,
Yeah.
but John's smarter, so
Well, you know how to file carve. You know how to
yeah, I know how
do
to
event
file carve.
logs.
This
The
is
only one you
easy.
might
I
not
know how
know
to
is
look.
like prefetch stuff, but you know that too. You took
Yeah,
McKinnon's class.
I did. That's my goat.
He follows me on LinkedIn. I talk to McKinnon sometimes.
Oh, that's cool. If we went to Gurkhan, you could see him at Gurkhan.
Oh well. I'm not driving to Michigan.
Sorry, Tosh and Muatas. I forgot to unmute again. Um, but yeah, okay. Activity section. What did you have to say on top of that?
That's pretty much it. Is these are the things we're gonna be doing. If you guys want to go to the presentation, Eli can share it with you. He can put it
Hmm.
up on the board for those of you in person. The lab files for all three labs are at this bit.ly link. I hope that still works at least because everything else for
It
this lab
does.
is
I
broken.
confirmed earlier.
Okay. So activity one, there's a person that wants a family photo recovered from a hard drive that doesn't work anymore. It is a JPEG file. Go carve it. Um, Activity 2, prefetch. A CSAM suspect was given a court order. He needs to not have any image viewers on his system and should not use them after the date of 2/10/26. You need to search through the prefetch files provided to look for evidence of any image viewer usage after that date. And then the last scenario is ABC Corporation believes that one of their workstations was attacked through the RDP user account, and you need to look through the event logs and see what happened.